Greetings to all. This is Dr. Satheesh Kumar, working as an associate professor in the Department of Artificial Intelligence, MITS Deemed University, Madanapalle. So today here I am to explain about the topic of the graph traversal in the subject of design and analysis of algorithm. Let's restart. So this is a flow of my today's presentation. So introduction about the graph traversal. Just so everyone know what is a graph. Just already we have studied in the data structure subject itself. So next is the general concepts of the graph traversals. What are the specific graph? How we are going to do the traversals in the graph, either in the tree. All right. So what are the techniques? What are the different types? Just we are going to follow to implement the graph techniques using that breadth first search and depth first search. So the main two techniques of the graph traversals. The first one is breadth first search, and second one is a depth first search. And after that, so we having a two important components. That is super graph in the graph techniques. That is one is a connected and bi-connected components. So let's see one by one. So first, the introduction to the graph traversal. So what is the mean by graph? Just everyone knows it is a set of vertices and edges. So just we can write always the representation of the graph is g of just everyone knows that just we are going to represent the graph g of v comma e. So the v is represent the vertices and the e is represent the some different edges in the graph. That is a collection of a node. So what is the vertices? It will be represented as a circles, also known as here the different collection of nodes to construct a tree or a graph. So what is the edge? It will be the represent as in the line. Okay, so simply we tell that is a connecting of the two vertices and connecting of the two different nodes in the graph, either a tree. So here, so what are the different terminologies are present in the graph or tree traversals? Just everyone know there's a node, edges, the adjacent node, then a degree of the node, the size of the graph, and path. So what is the node? Just different collection of the graph or a tree. Just we will represent. Right, that is A, B, C, D. This is a collection of different nodes. So what are the edges? That will be connected. The edges is used to connect the different nodes. That is a vertexes. It will be connected in the vertexes. So next one, adjacent node. So just if you are taking the different nodes in the graph or tree, the first just you will take the starting point. So from the starting point, A means what are the adjacent nodes are there for node A. So just we have to mention if it is a B is present in the adjacent node of A, so B is the adjacent node of your starting node A. So like that, just we are going to represent the adjacent node. So next one is a degree of node. So how many number of edges are connected with the collection of nodes, that will be the degree of the node. For example, the degree of node A. What is the degree of the node A? How many edges are going to be represented from the node A? That will be calculated. So size of the graph, just you have to calculate the level by the level graph. So just you have to represent the each and every edges in the graph. Okay, so in the first level, how many edges are there? The second level, how many edges are there? Likewise, just having how many levels are present in the graph or tree. Just we are going to calculate the size of the graph or size of the tree. The next one is a path. So what is the path? The sequence of vertices from the source to destination node. Okay, so from the top to the bottom, how we are going to travels either in a graph or tree. Just we are going to represent the path. Then just already said, just we having a different types of a graph or a tree. So here, so what is the types of the graph means? The directed or undirected graph. So directed graph means, as everyone knows, just each and every node it will be directed to the another node. One node it will be directed to the another node. Either it is a unidirectional or bidirectional, right? So the undirected graph means it's normally just we are going to all the edges or it will be connected to the different nodes in the or different vertices in the graph. Okay, next one is a weighted and unweighted graph. Just we are going to mention some different weights of each and every edges with the collection of nodes. That's a weighted. The next one is unweighted graph. Now that means Unweighted graph means just we are no need to represent any weights on the particular edges to represent the collection of different nodes. Next one is a cyclic and acyclic graph. Just we are going to mention the given, first just we have to mention the given graph as a cyclic or acyclic graph for implementing the either in a DFS or a BFS. So just already I said that what we are going to represent the two techniques to implement the graph, either a tree in the data structure and design analysis of algorithm. That one is, first one is the breadth first search BFS, and the second one is the depth first search, that is a DFS. So BFS, it will be purely based on the Q data structure. Just already we know from the data structure that we have learned about the what is the queue, what is the implementation of the queue in data structure. And next one is the first is based on the stack data structure. How we are going to implement the DFS using that stack data structure, just we will see. So next one is the breadth first search. The first technique of graph traversals in design analysis of algorithm is BFS. What is the BFS? The breadth first search. It will be implementation all the operation based on the Q data structure. Just everyone knows the Q data structure is a two basic of two operations. Just we are going to insert the backend, removing the nodes or element from the front end. All right. So here the breadth first search. If we are going to make a starting point of the graph, then we have to start either it is adjacent nodes, either one side, left or right. So it will be complete the visiting all the nodes present in the graph using breadth first search level by level. Okay, so the first level is a starting node. The next level, how many nodes are present, just we have to visit, then we have to move to the next level. So the breadth first search, it purely based on the level by level node visiting. So each and in the graph traversal, just a basic concept, just we have to visit all the presented nodes at once, only once we have to present. So here just we having a different concepts, just is there for using the BFS to travels in the entire graph presented in the one. So BFS is different from the DFS in a way of closest vertices, right? So how many vertices are present, how many edges are connected each and every vertices before that one. So we mainly travels as vertices level by level already is there. So the popular graph algorithm is like a Dijkstra's algorithm, Prim's algorithm, so Kruskal's algorithm is the main algorithm. If you are using the breadth first search to traverse each and every node in the graph or tree, this we can use. All right. So the BFS, it can be used to detect the cyclic or acyclic graph. It will be there present in the given graph or tree. Just we can decide using this type of algorithms or techniques. So the simple algorithm we have to follow to implement the BFS using the Q data structures. Right. So what is first one? Just we have to initialize the a node. Okay, so initialization means just for starting point we have to represent in the given graph or a tree. Okay, starting point. Just any node can act as a starting point. So I ensure that the given source vertices into the queue and mark it as a visited. Okay, just we have to create one queue and as well as then BFS expressions. Right. So first which node just we are going to visit, that will be stored into the queue. Then after that, just we have to remove from the queue. Then we have to insert into the BFS expressions. So like that, just each and every node just we have to visit. Then we have to insert in the queue. Then we have to remove from the queue. Then we have to move to the BFS expressions. So like this, just we have to visit each and every node to insert in queue, and we have to remove the queue from the queue. Then we have to insert in the BFS expressions. So like this, just we have to follow until the visiting all the nodes based on your breadth first concept. That's level by level. All right. So next one is the third one is the termination. Just I have to follow the step 2 until the completion of all the levels of the given graph. And then just we have to, when it is a queue is empty, then we have to terminate the particular steps to implement to proceed. Okay, so this algorithm ensures that all the nodes in the graph are visited without failing, without omitting any nodes in the given the graph using the breadth first search algorithms. It's an important concept if you are going the design analysis of algorithm. Just we have to calculate the time complexity, space complexity of a given technique, right? So in the previous lecture itself, just I said what is the time complexity, what is the space complexity, so what is the importance of the time and space complexity. If you want to calculate the given implementation, given algorithm or given operations, and then just if you're having any clarification doubts, just you go for that particular video, just you can watch and then you can get the clarification about the time complexity and that space complexity of the particular concepts. So here in the breadth first search, just if you want to do this on time complexity or space complexity, just we should know that which order it will come, right? So first just we need different vertices, different edges of a given a graph. So what, how many edges or how many vertices are present in the given graph, and what are the, how many levels are present in the graph, that also we have to calculate. Then just how many size of the graph, what are the total size of the no different nodes, just we comes to know. Then just we should calculate the time complexity of the given graph using the breadth first search. So in this one, based on the simple graph, as order of v plus e. So here this order means it will come some levels. Then just we already we know the different vertices, different edges, just we know comes to from the given graph. So this is about the breadth first algorithm to implement the given graph. So next we will move to the depth first search. Okay, so what is the depth first search? Just if you are starting from the one graph from starting point, if you are moving visiting all the nodes from either in the left side or right side, just we have to go until the adjacent node of the left side node, then we will move to the right side of the adjacent node. So like this, just we have to move to visit all the nodes at once using the depth first search, right? So just we having a different rules. Visit the adjacent unvisited vertices and it will be marked as a visited node. Then just we have to push into the stack. So depth first search, it will be work based on the stack concept. So stack operation, just to start, what is the stack operation? It will be the push and pop. Just we have to push visitors to stack a visited node into the stack. Then we have to using the pop operation to remove the particular visited node. Then we have to move into the DFS expressions, right? So what is the next rule number 2? If the no adjacent node vertices are found, pop in the vertices from the stack, then it will be moved to the DFS expressions. Rule 3, repeat the rule 1 and 2 until the stack is empty. So until the stack is empty, just we have to follow the rule and 1 and 2 to move from stack to DFS expressions. That finally just we will decide what is the path of the traversals using the DFS algorithm. All right. Here also just we need to calculate the complexity. That is a time complexity, space complexity based on the same in a BFS. So here just the different algorithms. Algorithms it will be working based on the different applications of DFS. That is the undirected graph. Undirected graph or a directed graph. Just we having two types of that graphs. There is undirected graph and a directed graph. In this undirected graph, just we are going to see the different concepts of component and bicomponent. Connected and biconnected component, articulation point, and bridges. Okay, in the directed graph means with the given graph, it will be the acyclic or a cyclic or topological short, or strongly it will be connected to components with all the edges and different vertices. The next one, just we will move upon the connected components. So what is a connected components? Just we having a given a graph, we should see the, if you are dividing the given the graph into the subgraphs, it should be the subgraphs also should be there some graph. It will be act as a some graph. In the given example, just I given in the given graph, just I am going to segregate it and I am going to split into the two graphs. So first one node 1 2 0 1 2 is like a one graph, and the node 3 and 4 is another subgraph of your graph. So here also we having a two components, two connected components. The first one node 1 0 and 2 is the component 1. Next node 3 and 4 is the another connected component. So here just we having two types of connected components, connected components 1, connected components 2. If it is so, it will be called as a connected components of your given graph traversals. Okay, so here just we having a different characteristics of the connected components. The connected components is set of vertices and set of edges in the graph that will be connected to the each other. The graph can have a multiple connected components. After splitting the graph in a number of graphs, or each and every graph should be the connected components. That will be called as a super graph. Right? Each and every connected components we will simply call as a super graph. Okay, inside a component, each vertex is reachable from every other vertices in the component. If you are splitting a number of graphs, if you are starting from one node to another node, it should be connected with the edges. Okay, so here just we having a two techniques to identify the whether the given graph is a connected component or not. That the same thing. Just we will use this to two techniques. One is the depth first search and breadth first search. Already we know how to use the depth first search and the breadth first search in the given graph. And the last one is union find algorithm. It's known as a disjoint set union. Just already we know that what is the disjoint set union. If you're having a different component, connected components, if you are joining with the some particular articulation point, it will create one graph or a tree. That is called as a disjoint set union. Okay, so just if you are using three techniques, just we comes to know that we can easily to find the given graph is having a connected components or not. Okay, so next one is a simple implementation of the connected component. Just we have to find the given graph or given tree as here having the connected component, or how many vertices or how many nodes are present inside the graph or trees. Okay, so here just we are going to find the given the graph is a connected component. Just we are to going to represent as a G. Then for each vertexes, just we having here V belongs to N. Okay. We have a different node, we having the different vertexes. Okay, so each and every node, just we are going to initialize the flag node as a -1. Okay, if -1 is it is a represent, it is a unvisited node. If you are representing here there one one, if you are representing and there one, it is a meaning of it is a visited node. Then just we are going to start the count of equal to 0. We are going to start the from the initial stage will represent 0. So just we are going to increase as we are going to visit each and every node from the graph using the for loop. Okay, for int v equal to whether the vertex is equal to 0, then vertex less than n, then just we are going to increase the each and every node. Okay, so here what is the condition? If the flag, okay, flag of the vertex is equal to -1, then we have to use either the DFS or a BFS algorithm to visit each and every nodes to represent the or implement the all the concepts. Okay, so this is a concept. Just we are going to use this simple method to find the given graph as a connected or unconnected. Next one, just we will move to the bidirection, bi-connected the components. Okay, so what is the bi-connected components? Already connected components, just we know if you are splitting in the graph, then we will identify, we will get some other graph, then we will do. Okay, so what is the bi-connected components? It is the main concept of bi-connected components. So first, just we need to find the articulation point in the graph. Okay, so what is the articulation point? The node of the graph whose removal would cases and in increasing the number of connected components. If you have to find in here in the graph, just 0 is the articulation point. For example, just I'm telling in the given graph, if 0, or the second graph 2 is the articulation point. Just if you are removing that articulation point, that is node 2, it will create another component. It will create the another connected component. If it is so, that is called as a bi-connected component. Okay, in the first graph, first example, if you are removing and that is 0 or some other node from the graph, it will not create the connected component. If it is so graph, it will just we have to represent the not a bi-connected graph. So thank you so much. If you're having any doubt, any clarification, just keep on post on the comments. Thank you for watching the previous video. Just keep on watching in this one. Just if you have any clarification, post your comments in the comment box. Thank you.